Okay, so we are into our second technique of integration. When we are given the integral of a function, the integral of f of x dx, our goal is to produce a substitution. We will replace f of x by u so that we can write it in the form the integral of u to the n du. And of course, you know what's going to happen after that. We will just apply our generalized power rule. You know what? The best way to explain this is really just to go straight to an example. Let us integrate this. So what do you know right now that can help you get the antiderivative? Well, what you can do is you can expand this. Okay? You can expand that binomial, and it's going to give you a polynomial of degree 5. And then after that, you can just apply your generalized power rule on each of the terms of your polynomial. But that is like a long job. Okay, it's not easy to expand binomials, especially when the power is more than 3. So this is the substitution that I'm going to do. Let u be equal to 1 minus 2x. So it's like u is another function. It's a function of x. And so we can think about du over dx, the derivative of u with respect to x is equal to negative 2. Now we can look at du over dx as differentials. Okay, so it's like small changes in y divided by the small changes in x is equal to negative 2. And so we can look at it actually as an equation. And so du is going to be equal to negative 2 times dx. Okay, so we already have an expression for this. This is u. What about dx? What will replace dx? Well, solving for dx from this equation, what we have there is dx is equal to negative du over 2. Okay? And so we shall now produce something like this. This is equal to the integral of u raised to 5. Okay? And then our dx will be replaced by negative du over 2. And we will apply our power rule on this function. So applying our generalized power rule, this is going to be negative 1/2 times u to the 6 all over 6 plus c. And that is just equal to, it should be negative 1 over 12. Okay, I'm sorry, it's not negative 1/2, it's negative 1 over 12 times 1 minus 2x raised to 6 plus c. Okay? Let us get the integral of 2 minus 3 times x dx. Okay, so let u be equal to 2 minus 3x. So you can look at u as a function of x. So what is du over dx? It's negative 3. Du now is equal to negative 3 times dx. Dx is negative du over 3. So we can now replace this by u. This one becomes u raised to 1/2. Dx will be replaced by negative du over 3. You have negative 1/3 there. We can bring it outside the integral sign. So it becomes negative 1/3 times the integral of the square root of u du. So that is a clean function where you can apply your power rule right away. So it's going to be negative 1/3 times u to the 1/2 plus 1. That's 3/2. All over 3/2 again, and then plus c. That is equal to negative 2 over 9. Again, simplifying this, this is the square root of u cube, okay? And the square root of u cube is equal to the square root of u squared times u. That's times. Okay, so this is equal to u times the square root of u, okay? the integral of the square root of 2 minus 3x dx. So we will just replace u again by the original function. So it's going to be negative 2 over 9 times this. This is your u. And then square root of u plus c. What is the integral of ln of x over x dx? Okay, so this is the substitution that I'm going to do. Let u be equal to ln of x. Du over dx is 1 over x. This means du is equal to dx over x. So this one is going to be u, and this one is going to be du. Okay? So we can write it simply as the integral of u du, and you know that to be equal to u raised to 2 all over 2. By replacing u by ln of x, you can write the antiderivative this way. It is equal to 1/2 times the square of ln of x plus c. Be careful about where you will write the exponent. Okay, you don't write 2x as the exponent. You put ln of x inside the grouping symbol, and then that's when you affix the exponent. Let us check. Okay, again, the integral is the antiderivative. Okay, so if you want to check if your answer is true, all you have to do is get the derivative of this function. What is the derivative of that? So applying your chain rule, 1/2 gets cancelled, okay, because you will bring down 2. 2 times 1/2 is 1. So you are left with ln of x times the derivative of ln of x. And so that becomes ln of x times 1 over x. And that is just ln of x over x. And look at that, look at that, look at that. That is our understanding of the integral. That is the antiderivative. If integrating this function leads to this means getting the derivative of this function should bring us back to our integrand, ln of x over x. Get the integral of e raised to sine of x times cosine of x dx. So our function is kind of, at the first glance, it's becoming challenging. Okay, it's challenging. So this is like a product of exponential function and trigonometric function, and this is also a function composition. So our functions are really becoming more challenging. But this is the challenge. What is going to be your u? Okay, what substitution are you going to do? Let u be equal to sine of x. Du, you know, is just cosine of x. So it's important for you to still know your differential calculus. The derivative of sine is cosine. So du now is equal to cosine of x dx. So this means this one will be replaced by du, and that one will be replaced by u. Okay, so now look at that. From something that is kind of worrisome to look at, now we see something that is just so beautiful and so simple. And you know that to be equal to e to the u plus c. Okay, the derivative of e to the u is e to the u. And we will just bring it back. We will just replace u by sine of x. Now, do you want to check if your answer is correct? What do? Well, you get the derivative of e to the sine of x. Applying your chain rule, this becomes e to the sine of x times the derivative of sine of x. And what is that? That is cosine of x. And so this becomes, look at that, e raised to sine of x times cosine of x. And that is precisely the function that we are integrating. So that is how you check if your antiderivative is correct. Get the derivative of your tentative answer. If it will get you back to the original function, then you did it right.